In looking at functions and functional notation, there are a few key terms that you need to know that are written here. A relation is a set of ordered pairs of real numbers. For example, 3, 5, 2, 4, 1, -1. This would be a relation. I can list them as ordered pairs. I can graph them on a coordinate plane. I can list them in two circles and show how they relate to one another, all different ways to represent a relation. Within that relation, the first value, typically the x value, is the domain, and the second value, typically the y value, is the range. And then a special type of relation in which an element in the domain has exactly one element in the range, in other words, x does not repeat, that is called a function. To recognize that something is a function, you can do what's called the vertical line test. So in other words, if I have a graph that looks like this, there is no place I can draw a vertical line that hits the graph more than once. Therefore, x does not repeat, and it is a function. In contrast, if I have a graph that looks something like this, I can draw a vertical line here, and it hits the graph twice. Thus, x repeats, and it is not a function. One of the things I want you to be able to do is evaluate functional notation. This is read as g of x, and all that means is wherever you see an x, you're going to substitute the value given. For g of 2, you will do 4 times 2 plus 5, which gives you 8 plus 5, which is a value of 13. Secondly, if I'm going to do g of -1, I'm going to plug in -1 everywhere that I see an x. G of -1 gives me -4 plus 5, which is 1. And finally, g of 0, I'm going to do the same thing and get a value of 5 when I plug in 0 for x.